In this video, we'll use Genoma to build a rig for a mechanical object, a robot arm that can be found among the LightWave 10 demo scenes. You can find the specific content for this tutorial in the relative thread in the LightWave forums. Let's load the object named Mechanical Arm Separated Layers. We have each independent part of the arm distributed in the layers. Let's ignore the base of the object in layer 1, since it will not be animated. We'll build our rig in the first empty layer available, layer 8 in this case. Let's leave layer 2 in background so we can use it as a reference. From the Genoma presets panel, let's choose Control 01B from the FK Controls folder. This sub-rig will create a single bone whose rotation and position are controlled by a single null controller. We can now move, rotate and scale the sub-rig so it's correctly aligned to the object in the background layer. We can select the middle vertices of the sub-rig and use the Set Value option to perfectly align them to 0 on the Z-axis. Then we can select the top vertices on top of the sub-rig and move them so the tip of the connector is about in the center of the disk that is part of the background mesh. To test the rig, the best thing to do is to copy both layer 2, the mesh we had as reference, and layer 8, the rig we're working on, in the first layer of a new object. That, from now on, we're going to use just for the purpose of testing if any change we make to the rig is working fine in layout. Let's save the object and send it to layout. We can use the Create Rig tool and check the result. Rotating the control on the bank should now rotate the bone as well, and of course the object. In Modeler, let's go back to the first object, keeping layer 2 and 3 in background. We can now copy, move and paste again the sub-rig. We'll be using the second sub-rig to control the mesh in layer 3. We can use the new Axis Translate tool to move the selected sub-rig exactly in the right place, simply dragging a line from the base of the sub-rig to the center of the little cylinder we have in background. Now we can edit the sub-rig to match the background mesh. Let's copy the 3 layers. Delete everything from the first layer of the Mech Arm Whip object and paste in the new geometry and rig. In Layout, let's click on Update Rig this time. The mesh will be deformed in a very organic way, something we really don't want to happen. To get rid of this problem, we need to define and assign some weight maps. I will select one layer at a time and assign a weight map to each one of them. W01 for the first, W02 for the second, and so on. We want to assign the proper weight map to the sub-rigs. Let's select the main bone on the first sub-rig and assign the weight named W02 using the Set Skeleton Weight tool. We can do the same for the second sub-rig, assigning W03 to it. Let's copy the 3 layers again in our test object. Again, do not forget to delete anything you have in layer 1. Back in Layout, let's update the rig again and test it. The weights have been assigned correctly, and now we have a rigid skin for the deformation. But we still have a problem, since rotating the first control should affect the second bone as well, while now they're moving independently. This happens because we didn't connect the 2 sub-rigs in Modeler. Back in Modeler, let's select the tip point of the orange connector of the first sub-rig and the base point of the second sub-rig and weld them. We can now test the result in Layout, updating the Genoma rig and playing with the controls. Now the hierarchy is working properly. I will not describe the following steps, since they're all pretty similar. Basically, you have to add the same sub-rig and adapt its position, orientation and scale to each object layer and connect them properly using the connectors. Of course, you will need to assign the proper weight map as well. We should always remember that Genoma is a rig modeling system, allowing any modeler tool to be used for editing our sub-rigs. It's very important to keep the object we're editing the rig in and the test object separated, since that way you will always have a one-layer object in layout, which is something required by Genoma when creating a new rig. Let's talk about the green arrows you can find in the Genoma rigs. Those green arrows define the orientation of the controls and the bonds that will be created by Genoma in layout. Somehow, they act as pole vectors. Using them, we can decide how rotations are going to happen. Let's take a look at this control. It is placed exactly on the back of the bond in Modeler. In layout, we can notice how this situation defines the heading, bank and pitch orientation. Let's go back in Modeler and change the position of the control. I'll move it on the side of the arm this time. If we update the rig in layout, we'll notice how now not only the position of the control has changed, but even its orientation. Now the pitch, heading and bank are oriented in a different way, both for the control and the associated bond. Let's try moving the control in a different position, and let's check how this affects the final orientation in the rig. As we can see now, the axes are not aligned to the world anymore, and when we rotate the control, of course now what happens is not what we wanted for our rig anymore. As you can imagine, bonds can bend in different directions, according to the shape of the mesh. The green arrow let us define the bending rotation of any part of the mesh, such as the bonds of a finger in a character, in a very precise way, so they bend correctly. Let's go back in Modeler and move the control back to the right position. I want to show you how powerful Genoma can be, letting you do things that would be impossible to achieve with other rigging systems. Let's mirror the object and go back in layout. If we update the rig, now we'll have two mechanical arms rigged and perfectly working. Let's do more. Back in Modeler, let's rotate one of the two objects. Since we're rotating the whole rig as well, the rig created in layout by Genoma will be working perfectly, respecting the right orientation of all the controls. Of course, being able to use any tool we have in Modeler to edit the rigs gives us a lot of possibilities. Let's delete one of the two arms and apply a radial array after moving the object on the z-axis. Don't forget to select the object before applying the radial array and to delete it after the operation, or you'll get two overlapping objects. Back in layout, let's update the rig. Now you get 8 arms, all perfectly working. We didn't add the base of the object yet. Since it will not be moving, we can simply copy and paste it in the test object, and everything will be fine. Something we may want to do is to lock the axis that shouldn't be used. Something pretty quick to do. I'm planning to add some sub-rigs that will automatically lock the axis for us. Genoma can really help making the creation of any kind of rig a very quick operation. Of course, there's a lot to discover about it, especially considering that it allows to literally model your rigs and save them as presets that can of course be adapted to any mesh.